Hey, how's everybody doing? Let's continue on here with our Chapter 2. This is 2.6, Families of Functions. Our essential question, what is a translation of a function? Okay, we're just going to touch on a couple of things here, get into it a lot more when we get into absolute value, and then you'll see this continually as we talk about quadratics and cubes and different things that we graph. A translation basically is a shifting of the graph or the line horizontally or vertically. Right now we've been mainly dealing with linear lines, y equals mx plus b, and looking like this right here. And as far as the translations really apply here, mainly what we're looking at is a vertical shift up or down. Okay? And I gave you a couple of examples here. I started with, if you look in the book, it talks about a parent function. That's like the beginning or the base function that we start with, and y equals x is that base function for a linear as far as a parent function. And it starts here with a y-intercept of 0 and a slope of 1, and that middle line right there is y equals x. That's like our starting point. When you add or subtract something from the x, what that does is it moves the graph up or down. Because if you think about here in the red line, x plus 2, we got a y-intercept of 2 with the same slope of 1 that this one has, up 1 over 1. You get a parallel line to our parent function, only it's translated up 2 spots. Okay? And if you had x minus 3, you would go down from the origin 3 places with your slope of 1, just like they all have. And then you're going to see that's parallel also. That's a translation of the graph. Here it's mainly just vertical, up and down. When we get into absolute value here next week and some of these others, we'll also shift it right and left. You'll hear terms like compressed or stretched. We get into that a little bit, but mainly you're going to be able to look at an equation and know where it starts from, whether we're talking about a vertex of a absolute value or a quadratic, and how we would translate or move that graph just by looking at the equation without having to plot a bunch of points. So, but as far as the linear goes, you'll notice the slopes are the same. Our parent function is y equals x, and if you add, you're going to move up. If you subtract, you're going to move down from the origin, all having the same slope, and that's a vertical translation. Next, I want to talk about a reflection. Okay, reflection is like you see your reflection or your reflection off of a pond or something like that, or reflection off of a mirror. What a reflection does is it flips a line across an axis. Okay, I think it's probably easier to see this with a picture. If this is our parent function right here, or our f of x, if we were going to reflect this over the x-axis, then you're going to flip it down over the x-axis. Okay, hopefully I think with the picture there you can see how this has been reflected over the x-axis. And if we reflect it across the y, you're taking this and you're doing that with it. Okay, so it wouldn't be the same shape. You got to think of it just taking it and flipping it over. Okay, so that's how a reflection looks like. When we're talking about a reflection of an absolute value or a quadratic, you'll see if they're going up, then they're going to go down. If they're going right, then they're going to go left. It just that's how it goes. It just has it go in the opposite direction. In the section, they have a nice little summary there. Maybe a little confusing, but to try to simplify it, we start with our parent function, y equals x. If we add something to it, we're going to move up from the origin, 0, 0. If we subtract something from our x, we're going to move down, and the graph stays looking exactly the same. It's just translating up or down. But if we reflect it, okay, then there'll be a negative out in front. That's how you denote the reflection. It's the negative of it. And you can see what I did here. If that's f of x, this would be negative x, or the reflection of it, and you have to signify which axis you want to go across. So y equals negative x, you now got a negative slope. It's doing this because this part, because it looks like this. You've got this. This part's going to reflect down here, so it's going to be here. And this will reflect this way if you're talking about reflecting over really either axis. But if you want to go across the x-axis right here, this part would move down here, this part would move up here, so they're reflecting over the x. And it just so happens with this particular function, if you wanted to flip it across the y, that would go here, and this would go there. So you end up with the same line either way for this particular function. So that's translating up and down basically for linears. We're going to get into this much more. And something that you'll notice too as we go through this, a lot of similarities with the different graphs. Okay, you'll see similarities here vertically and horizontally, whether we're talking about a line, an absolute value, a quadratic, graph in the square root, or whatever. You'll see as we do that and progress through the year. So hopefully this has been helpful. When you get in class tomorrow, we'll take a look at some of these problems out of the book and a little application of it. All right, hopefully that's been helpful. See you tomorrow.